A capacitive proximity. A typical capacitive proximity sensor uses two capacitive plates located side by side in the sensing head, powered by electronic circuitry, which includes an oscillator. The capacitors insulate. The amplitude of the oscillation increases when a metal object enters the electrostatic field. The amplitude of the oscillation also increases when a non-metallic object enters the electrostatic field, because the object displaces the capacitor's normal dielectric and changes the reactance of the capacitive plates. The detection circuit senses this increased voltage in both cases and closes a switch that energizes the sensor output. The oscillator amplitude returns to normal when the object leaves the electrostatic field, causing the switch to open. Any factor that affects an electrostatic field can impact the performance of the capacitive proximity sensor. There are 5 main characteristics that can affect sensor performance: target material, target size, target distance, sensor head size, and capacitive proximity sensors can detect metallic targets at greater distances than most Capacitive proximity sensors detect non-metallic targets at different lengths, depending on the target material, because different non-metallic materials affect the reactance of the capacitive plates differently. Materials that are easily polarized by a magnetic field, such as rubber, change the reactance of the plates much more than a material such as paper, and are therefore detected at greater distances. The dielectric constant of a material indicates how easily a material is polarized. Materials that are easily polarized, such as rubber, have a higher dielectric constant than materials such as paper. Many capacitive sensor manufacturers provide charts outlining the dielectric constants of common materials, as well as a procedure to estimate the sensing distance of a capacitive sensor using the dielectric constant of the target material. For example, using the graph shown here, a sensor with a rated detection distance of 20 centimeters could be Capacitive proximity sensors detect large targets at greater distances than smaller targets of the same material, just like inductive proximity sensors. Capacitive proximity sensors have a limited effective sensing range. For example, one sensor manufacturer offers devices with effective ranges up to 50 millimeters for metallic targets, 45 millimeters for rubber targets, and 25 millimeters for wooden targets. Many capacitive proximity sensors also feature an adjustment screw that allows the effective sensing range to be lowered from the maximum. Capacitive proximity sensors with a larger sensor head produce a larger electrostatic field and therefore have a greater sensing distance than sensors with a smaller head. Sensors mounted near metallic objects or mounted inside other electric or magnetic fields, such as fields generated by other sensors, may exhibit a reduced ability to sense a target. The sensor's data sheet will list any mounting constraints, such as minimum openings of a recessed mounting and minimum distance to another sensor. Although capacitive proximity sensors can detect metallic objects, they are typically used to detect non-metallic objects. Many automated filling machines use capacitive proximity sensors to detect the fill levels of various liquids and powders stored in non-metallic containers. For example, an automated beverage filling machine may use a capacitive proximity sensor to detect the water inside a plastic bottle. The capacitive proximity sensor detects the water but not the plastic bottle because the dielectric constant of the plastic is much lower than the dielectric constant of the water. Another application of a capacitive proximity sensor is the detection of plastic parts on an indexing table. The sensor detects the parts as they rotate around on the table and signals to the machine's controller to perform the next process step. A capacitive proximity sensor on a conveyor line cannot detect parts as they pass. What could be causing this?